Hello everyone, welcome to Tizen webinar presentation. My name is Chunwon Park, nickname is the Hermit. I'm a software engineer at Samsung Electronics. I'm a specialized in the Tizen UI framework EFL and I have contributed to the Tizen UX, UI and Tizen graphics, some convenient tools for application development since 2009. Today we will look how to design and implement complex native application layouts with Tizen SDK. Even this topic is intended to the listeners, Tizen native UI application designer and developers, but we want to look at Tizen or EFL overview, SDK installation, or some basic preparation for development so far. So, if you have no idea about the Tizen or EFL error, please refer the previous webinar videos or Tizen native application development documentations. Okay, let's check the application view basic concept first. In general case, an UI application is consisted of the views. In case of mobile and wearable apps, they are managing the multiple views by using NaviFrame widget. And one view could be composed by combining several container widgets, and the view could be completed its looks by putting some UI controls in the containers. But most of the cases, it's enough to use a list widget as the content of the view. Let's look at the setting application that's installed in default SDK emulator. This setting application is using the list widget. Exactly, it's called GenList. GenList means general list, but it provides a variety of many pretty functions. Just by using the GenList, you can compose your application views with various forms. By putting the GenList into a NaviFrame, a view displays the title and its actual content. So here, scrollable content is a GenList, and title of top area is the part of the NaviFrame. Let's select one item of the GenList. Next view comes, and this view is using the GenList as well. One more select one item ringtones. Even this view is composed with the GenList. Let's go back to menu screen and let's see another application views. This App Store app is one of the sample applications that SDK provides. This application view is composed with a more complex layout rather than list form. For constructing the various layout forms like this layout, EFL provides container type widgets such as box, table, and grid. Box is the most basic container widget. Box supports putting the content linearly to vertical or horizontal direction. Table is something like a two-dimensional box. You just put the multiple contents into a table at a specific row and column position. And grid is a little more complex. It's available putting contents at a arbitrary position and with arbitrary size. These position and size will be 0 to 100 in percentage unit, and these values are relative to size of the grid widget. Therefore, your content inside the grid will be scalable. Whenever size of a grid widget is changed, the content position and size will be also changed according to the grid. Until now, we will look at the basic containers in EFL. If we combine these containers together, we can construct the layout different and construct the layout more efficiently. In some cases, application needs more options for their one layout. For instance, how about this layout in the screen? if the size, width, and height are changed, or what about if its aspect ratio is changed? Even though the screen size is changed, some content in the container require the pixel size, or some cases, this content should be stretched to the width or height, or both. Sometimes, application may need a dynamic layout. It may need dramatical animation in real time. EFL provides Agile library for this case of similar complex layout design. In point of the application development view, um, app developers use Agile script language EDC to write their one's layout design. The layout written in EDC will be scalable and animated. Even you can write some tiny program logics with EDC. EDC files will be compiled to EDJ binary files when your project is run in Tizen ID. And these EDJ are to be loaded from your application in runtime. You can simply load the EDJ file by using the elementary layout widget. The benefit of the using EDC is in splitting the design and functionality parts. You can write new application logic with your preference languages such as C or C++, and you can write down only the layout design part with EDC. That means your application scene could be more expandable. It will report more expressible scene change only by switching the EDG file. Now you may wonder how EDC script looks like. Let's look into the EDC file format, badge structure. There are some definitions: collections, group, images, parts, part, programs, and program. One EDC file must have one collections necessarily. Collections is the list of the groups that composes one theme. In other words, one edited theme has the multiple groups and each group corresponds to your layout. Simply, you can load the EDJ file and bind the group to a layout widget with layout widget API elem layout file set. Basically, each group is consists of two parts, parts and programs. Part is the list of parts. Each part corresponds to a design element of the theme. The types of the parts are the specific color of the rectangle, image, text, etc. And programs is the list of the program. By describing each program, you can define or set some behaviors for each part. Normally, we can change the state of some part with program. For example, change the color, change size and position. And last images is the list of the image. Each image just describes the image file resource name if there are some image parts exist in a group. Frankly, there are lots of functions that EDC script provides. This time we just glanced down how EDC script looks like, but you may need to learn EDC grammar so far. Please refer the Tizen development documentation for more details. In the Tizen 2.3 SDK, it supports EDC editor tool. The name is Inventor for better development convenience. Inventor provides better dynamic development environment so that you feel writing EDC is more intuitive and easier. Now let's look some examples. Create one project. In the ID, choose a file, new, Tizen Native project, choose a template. In the mobile 2.3 profile, choose UI application here and basic UI application etc. If you watch the Tizen Native UI Application Development webinar, you may know what does basic UI application here. But here we second one is for our applications that layout will be designed with etc. So let's click the second one. Type some project name, simply webinar underscore etc. It's enough, and then click finish button here. First, let's compile project immediately and let's see the application screen. Here on Edge, Tizen Native Application. Okay. I'm building and installing the package to the emulator binary. And actually, I already launched the emulator. So, okay, here only hello EFL one text is displayed. Go back to editor and let's see the project code. Here, create a basic GUI function is the major function to create and set up some basic widget, and when application is launched, it creates a window, create a component widget, and create a base layer widget. Window displays some drawing things in each area, so all UI apps need one window at least. Component is a widget that controls the basic frame of your application views to shrink or expand. For example, if the virtual keypad is appeared, then your application view should be shrinked to not be hidden by keypad. Here, component widget will handle your layout size magically. And here, base layout corresponds to a base view. Create a layout and set a EDJ file by calling lm layout file set. This API requires three parameters. First is the target layout object, and second is the edge file name including path, and the third is the group name that exists in the EDJ. So here file path is EDJ underscore path, and this is actually EDJ slash webinar underscore EDC dot EDJ. You can see the origin EDC file here. If you double click the EDC file, Inventor tool is launched. But be aware, this inventor is only available in the Linux SDK version at this moment. You can see this EDC file just have one main group and one text title part. And actually this text title part its type is text. That means this part could print some text. Here you can see the text attributes, font, and font size, and its font color. The color will be black. Let's see C code again. Here it calls lm object part text set API that sets some text to a part of the layout. Here second parameter is the part name, text title is the target we wanted to set the text, and the third parameter requires the actual string to be displayed in the layout. Here we pass a hello EFL. With this API, application could set the text to each scenario in runtime. Let's go back to EDC. Let's do something here. Actually, this inventor has two parts of the views. Left side is the live view that displays the result of the EDC editing in real time, and right side of view is the EDC editor. But at this moment, there's nothing to be displayed. So just current live view is just empty. But if we set some exact text in the text part, we will see the result right moment. Let's set some text here. Welcome to webinar. As you can see, inventor live view displays the layout result. Let's change the color to some red, and let's change the font size bigger, and let's add a new part here. We add a rectangle part here and describe a default state. Description state means the state of this part. We can set the default position, size, and color in this default state. Let's write down rel1.relative 0.5 0.5. This means the left top position of this part, and since the unit is a normalized value, this part will be started at the center of the layout. And set rel2 relative to 1.0 1.0. This rel2 relative means the right bottom position of this part. And set color to red. So now we can see the rectangle part in the live view. As I mentioned before, group has the program part. Let's do something with program now. Describe programs and write one program. The name is clicked. And write signal mouse clicked 1. Signal means the event name, and this mouse clicked 1 is actually predefined event in the edge. So when some mouse click is happened, this program will be triggered. We need to set the source, which part event will be triggered from, and describe the action, status set to clicked, and set the target rectangle to do this action. But this rectangle doesn't have the clicked state yet. We need to describe the clicked state. Here inherit means inheriting all attributes of the state from the default, but we only override the position and each color. Okay, let's see the result. Let's double click the program, then this program will be triggered virtually. If you want an animation, then we can set the animation style here. Animation, get a linear interpolation per 1.0 second, and let's see the result. Here the rectangle has changed with the animation. As you do, interpolate the state changing magically, so we can see the animation so far. There are pretty nice EDC template code to start your own EDC file. If you create a new EDC file, then their inventor guides you to choose a template code. Let's create a new file. Click the Other, Tizen, and EDC file, and webinar.edc. We can see the list of the template code in the right side and the preview of the template in the left side of the pop-up box. These templates not help you write code quickly, but give you the message how to write the EDC script with the fancy features also. Transition, some map effects, image twin animation, and so on. So I recommend you refer the template code if you are not familiar with the EDC script yet. Also, you can refer the inventor documentation. What does inventor help you to do more things with utility functions? You can refer those things in this documentation. So it's time to conclude. We will look at how to compose one native UI application view. Basically, Navy Frame plus Genist is the standard to compose the view. For more various forms, EFL provides container widgets such as box, table, and grid. For more complex layout, we can use the EDC. It's recommended to use the EDC when you strongly need the dramatic layout. For example, complex and some changeable layout, scene-based layout, and animation support, and so on. An inventor tool will help you write EDC more quickly and easier. Until now, thanks to listening my webinar presentation. If you have any questions about Tizen EFL, then please send the email to chunnan.park@samsung.com. Thank you.